Here we are on the last page for the preparatory assignment using the MAT 131 student survey. The first question asks us to find the 5-number summary for the variable distance. So the data set that I'm going to use for this video is the fall 2022 data set, and of course you're going to use the most current data set, and the values will be different but the process will be the same. So let's start with the data set. We are in fall 22 and we want the 5-number summary for distance 2. So we're going to use the summary stats command. I select columns and then I select distance underscore 2 and then I hit compute, and in the window we see the 5-number summary would be the min, Q1, Q2, which is the median, Q3, and then the max. So the min is equal to 0.3, Q1 is 6.7, Q2, or the median, is the next number, which is 12, Q3 is next, 24.7, and then the maximum value for this data set is 284. So what do these numbers tell us? Q1 tells us that 25% of the students who answered this question have a distance less than or equal to 6.7 miles away from college, and that also means that 75% of the distances are more than 6.7 miles. The median is the 50th percentile, and that means 50% of the distances are less than or equal to 12 and 50% are more than 12. Q3 is the same as the 75th percentile, so 75% of the distances are less than or equal to 24.7 and 25% are more than 24.7 miles. And then the maximum value is 284. I'm sure that is an online student. Question number 2 asks to find the percentage of students who have a distance of at least 50 miles. At least means 50 miles or more, and they want us to use the dividers percent option. So we can use a histogram or a box plot. I'm going to use a box plot, and I'm going to select distance underscore 2. I'm going to make the box draw horizontally, and down here's my dividers. I want it percent. I hit compute, and there's the graph with the dividers. Now I'm going to make my graph a little bit longer so you can see it in the video better. And this is my slider, and we want a distance equal to 50 miles, so that looks about 50 miles. And if I click this box, this rectangular box up here, double click on it, I can type in the number that I want on the x-axis, 50 miles, and we see that 96.3% are less than 50 miles and 3.7% are 50 miles or more. So that's what I'm going to type in, 3.7%. Add my percent sign. Okay, the next question says determine the percentage of students who have a distance of at most 20 miles. Now that means less than or equal to 20 miles. So again, I'm going to use my slider, get to about 20. I'm going to double click on it, type in 20, hit compute, and here we can see the divider, it again is cutting the data set into two parts. We have less than this value or more than this value. So the answer is 64.1% at most 20 miles. So this would be 64.1. Add my percent sign. Next question. Now we're using credits. How many students? So this time we're doing a frequency, not a relative frequency. We're full time. That's at least 12 hours. So now I'll go back. I'm going to go to options and edit. Now select credits. Change the dividers to a count. Hit compute. Okay, this is more of a symmetric distribution. And I want 12. So I type in 12, hit compute, and we see 129 students are taking 12 or more credits. 115 are less than 12. Want to type 129. That would be our answer, and again, that's a frequency. There's no decimals. And we can verify this by using our table command. The table command can be used for qualitative and quantitative data. Frequency, and if I go to credits and hit compute, and if I add these frequencies up, 60 plus 24 plus 17, 15, 5, 2, 2, and 4, I get this 129. So that's a way you can double check yourself. So we're ready for the next question. Find a quantitative variable that has outliers to the right. It would be useful to think of a distribution that is skewed right. The first one that comes to mind for me is age. So if we go to options and then go to edit, I am going to select age. I'm going to turn off the dividers and I'm going to keep it horizontally. Hit compute. Yes, we do have some outliers to the right. Looks like there's 1, 2, 3, 4, 5, 6. 6 outliers to the right. And when we have raw data and we create a graph in StatCrunch, if you put your cursor on the graph, it will tell you the quartiles, the min and the max, so the 5-number summary, and it also will tell us the number of outliers. So I counted 1, 2, 3, 4, 5, 6, but this is saying there's actually 9. And the reason why is because there's probably multiple values here, and you can select them and then come over here and look down at the bottom and you can actually locate these, and we see there's 9 rows, so there's 9 students who are considered to have an age that's an outlier. So this would be variable age, and of course you can use a different variable if you wish, or you can use age, that's fine. And for this data set there's 9. Your data set will probably be different, have a different number of outliers, and that's okay. And now we want outliers to the left, so this is now going to be a skewed left distribution. Let me clear this out. Skewed left, the first thing that comes to mind would be maybe Cincinnati, or it may be happiness. Let's do happy. Hit compute. Yep, we do have some that are to the left. I knew this distribution was skewed left. Looks like we have 4. And again, we can put our cursor here and we can see that there are 5 according to StatCrunch. Now if you put 4, I would give you credit. When we have a graph here, there could be multiple values here that we don't see, and that's okay. And there's 4 outliers to the left. Okay, the next question asks us find a quantitative variable that has outliers to the left and the right. So if we go back to the data set, let's try height. That may have, nope. Let's try Ideal height, let's try that. There's 3, looks like 3 to the right. That's not what we want. Height difference, probably not. Shoe size, 2 is probably have 1 to the right. Let's try 3. Again, the difference between these two is the shoe size underscore 2 is including shoe sizes from other countries, and a lot of times those are larger than the US way of measuring shoe size. Okay, so here's 1. I bet you if we go to 3, it will be the same thing. It is. So that's one variable. Let's see if we can find another. Let's take a look at speed. This might be one. Yes. Okay, here's one. We have a lot of outliers to the left and to the right. Let's first examine these. So it looks like there's 19 here to the left. Okay, let's clear this. 19 to the left, and how many to the right? Looks like 9. So 19 and 9, and we're doing speed. And 19 and 9. And then the last question asks us to create a box plot for age separated by the variable seasons. So seasons is a qualitative variable: fall, spring, summer, and winter. So it's going to take age, then separate it by each of those 4 seasons, and then we can compare these. Go back to StatCrunch. Let's clear this. Let's go to options and edit. We want age, and then we want to group it by, which is here, by the variable seasons. There's season. Hit compute, and this is one of the nice things about box plots is we can compare different data sets all in one graph. And just by looking at this, I can see that fall has the largest median. It's more to the right. And I can also see it looks like the IQR, which is the width of the blue box, it looks like that's the largest, and summer may even be the same. And again, we can move our cursor to each one and actually see. So the IQR for winter is 9, the IQR for summer is 10, IQR for spring is 7, and then IQR for fall is 11. So fall has the largest median, and it also has the largest IQR. So which season has the largest center? Okay, so if we're using a box plot, the only measure of center that we can report is the median. So this would be fall, and the median would be 22, age 22. Which season had the largest IQR? Again, that was fall, and that was 11. Which season has the smallest range? Okay, so the smallest range, does this calculate range? It may be easier if we use our summary stats command. Go to columns, age, we want to group it by season, hit compute, and we can see that the smallest range, there's actually 2, fall and spring have the smallest range. The largest is summer, 41. It asks for the smallest, so that would be fall, right, fall and summer. And let's double check that. Fall and spring. That was 30. Double check it. Yep, 30. And then which seasons have outliers? Well, winter to the right, summer to the right, spring to the right. Fall's the only one that does not have any outliers. So winter, summer, and spring. I hope you enjoyed this video. Thanks for watching.